Thank you for the introduction. For my case study, I'm going to present the subject of emissions monitoring along with a few applications. The topics that I'm going to cover are: what are emissions and where are they coming from? What is emission monitoring? Why is it important? A customer application called the green feed system, and a second customer application, emission monitoring by drones. So what are emissions and where are they coming from? In the United States, most of the emissions of human-caused greenhouse gases come primarily from burning fossil fuels, coal, natural gas, and petroleum for energy use. Point sources of emissions include factories and electric power plants. Mobile sources include cars, trucks, of course, but also lawnmowers, airplanes, and anything else that moves and puts pollution into the air. What is emissions monitoring and why is it important? Emissions monitoring is a general term for ongoing collection and use of measurement data or other information for assessing performance against a standard or status with respect to a specific requirement. Emissions monitoring can detect gas leaks, reduce greenhouse gas emissions, improve facility safety, and resolve odor problems. Data measurements from monitoring are used to determine compliance with regulations limiting the amount of pollution that a source may emit. The green feed system by CLOC. CLOC has developed a patented, very unique system called the green feed. It is designed to measure methane fluxes from the breath of large groups of animals to provide farmers and researchers with real-time data to document improvements in feed efficiency and lower methane emission losses. So how does a green feed system work? The green feed system requires each animal to wear an RFID identification tag. When the animal approaches the green feed, it dispenses a small amount of feed to bait the animal into the feeder and keep it there for about 3 to 5 minutes. While the animal is eating, a fan is used to pull air around the animal's nose into an air collection pipe where airflow, methane concentration, and other parameters are measured. From these measurements, methane flux can be accurately determined during the visit. When these measurements are repeated 20 to 30 times over a period of time, an accurate average of methane flux for that animal can be determined. After the visit is over, the green feed is available again for the next animal. This enables the green feed to measure methane fluxes from many different animals in a herd. Methane emissions is representative of an animal's health. Low methane emissions can be an indicator that there is a problem with the animal. So what are some of the benefits of the LGD Compact in the green feed system? Axetris asked a question to CLOC: why did you choose the LGD Compact for your application? CLOC's response was, it was because of the stability over time and sensitivity to methane at very low concentrations. It is also more selective for methane than NDIR sensors, and it is small enough to easily fit within the footprint of the green feed system. What are the value that the LGD Compact brings to the green feed system? CLOC responded, we have a more stable and sensitive sensor, provides more options and flexibility to the green feed system. Also, a more reliable sensor means less maintenance over time. Here is our second customer example. Explicit, a Danish company, are measuring methane emissions from biogas plants. Rather than have me talk about them, we'll have a video to show.
So why do we use the drones for emissions monitoring? Because the drones allow us to get in the air and capture emissions that would otherwise be difficult or even impossible to measure. We don't just want to know where the leaks are, we want to know how much is coming from a facility. That way we can track reductions or increases over time and see whether we're making climate progress. So there are three main challenges for putting gas sensors on drones. First, they have to be light enough not to hurt your flight endurance. Secondly, they must be sturdy enough not to be compromised by the movements or the electronics of the drone. And thirdly, you need detection ranges that allow you to detect even low concentrations in the atmosphere. The LGD Compact for CH4 monitoring accomplishes all that, which is why it's ideal for us. With the LGD Compact, there are particularly two things that are very impressive. One is the sub-ppm detection level, and the other one is the no need for recalibration in the field. That means we have high accuracy and less maintenance. So we've got several key features to a drone like this one. First and foremost, of course, we've got the LGD Compact here, which allows us to detect even sub-ppm levels of methane in the air. But in addition to that, we've also got these wind sensors on the arms here that allow us to detect the wind signals as well. And the arms, we can move them as we fly in order to get as clean a signal always. And through the combination of both the gas and the wind signals, we're able to calculate the total emission rates from a plant like this one. So right now we're focusing on methane, but we've also got our eye on other gases like ammonia or CO2. If we want to combat climate change, we need to get better at monitoring emissions. For that, we need good sensors like the LGD Compact from Axetris, but we also need innovative methods to monitor these emissions, like what we do at Explicit.
So in summary, do you require a small sensor for methane detection which is reliable without continuous recalibration? Do you require long-term stability for detection of methane in sub-ppm range day in and day out? Don't think twice, just test a new LGD Compact. Thank you very much for your attention, and we look forward to your questions.